All right, so Minerals of Australia, the C list, part 1. So we're going to be looking at the minerals from Cacoxenite through to Chromite. And first of all, just I suppose a bit of a plug. I've already published now electronically the first volume of the Illustrated Minerals of Australia, and that goes through from Chalcanthite through to Cerussite. And just a few stats on that. It's full color. It's an electronic version only. Print costs would be crazy because it's 715 pages in length. It covers 348 species, and there are over 1,050 mineral photos in it. And just a little bit of a recap on the geography, at least, of Australia. And Australia is comprised of 5 mainland states. So it's Queensland, New South Wales, and Victoria on the right-hand side there, South Australia and Western Australia, and then Tasmania being off the main part of Australia, and then 2 territories, the Australian Capital Territory and the Northern Territory. And there's a few other territories as well, but much smaller. So Christmas Island is one in the Indian Ocean, Heard Island, which is within the Antarctic Circle, and a couple of others. But from a mineral perspective, the vast majority are from the mainland or Tasmania. Right, now for each of the minerals, what I'm going to be showing is the mineral name up in the top left, the formula in the top right, which if I keep my little thumbnail out of the way, you should be able to see that okay. And then, excuse me, from the publication itself, just a list of selected Australian occurrences. In some cases, that's only one. In other cases, it can be many, and it doesn't list every single one. But this gives you an idea of the breadth of the occurrence of the particular mineral. So for Cacoxenite, we've got occurrences in New South Wales, South Australia, in Victoria, but particularly the South Australian ones. South Australia is best known for its phosphates. And then what we have then is a few photos, one or more photos of the species. So in this case, we've got from the Hicks quarry in South Australia, typical sort of yellow fibrous crystals of Cacoxenite. It also occurs in sort of globular masses, such as this one at St John's quarry in Kapunda. St John's is, I think, one of the ones that is filled in these days, so there's no access to any material there anymore. A lot of these are from older collections. And then from the state that I live in Victoria, but the other side of Melbourne, we have, again, globular form of Cacoxenite, but these are less fibrous, and you can see the ones at the top, you can see that there's still that fibrous nature there, and it's zoned as well, where the center of it is a darker color, which means that there's probably maybe a bit more iron or whatever in it. And another one from Victoria here, which is on goethite, iridescent goethite, which is quite attractive. Then we have Calaverite, which is a gold tellurium species. It's actually quite widespread, but not very well known from localities because for the most part, it's just a minor ore mineral or part of a primary ore. And you can see the third one there as microscopic grains at Mount Lyell. So it's been picked up in when ore has been analysed, rather than it being a visible mineral that you can have in your collection, except, however, in Kalgoorlie in Western Australia. And that is that there are a lot of tellurides there. There's obviously a lot of gold there, and Calaverite is one of the telluride minerals and occurs as the lighter coloured material here. I think it's with see, it's another telluride mineral. I can't remember what one off the top of my head, which is the top of my head, which is the darker mineral. But that can come in quite large, relatively large masses. Calcioferrite is a rare one. It's only been found at one locality, and that's the Macolta phosphate quarry in South Australia. And that forms these pale yellowy green hemispheres. Oh, the other thing I should say is you can see the scale down the bottom alongside the locality as well. Excuse me. And this orange sort of matrix is quite typical of the matrix of quite a few of the phosphate quarries in South Australia. Calcite. Surprise, surprise, there's more than one or two localities. What I've done here is just for each state listed a few key ones. So New South Wales, Broken Hill is probably the best known of those. Queensland, the Cloncurry region, Red Dome in particular has some very nice calcites. Range ones in South Australia and Tasmania, and Victoria, because Victoria is well known for zeolites, it's also well known for associated calcite as well. And a few examples: Broken Hill, a lot of the Broken Hill ones fluoresce orange or orange red. This one here is from the museum in Broken Hill, the Albert Kirsten Mining and Minerals Museum, and it's a large specimen. I don't know exactly what size, but it's going to have to be probably 35-ish centimeters across, so it's a good size. Also from Broken Hill is this Manganone calcite. This is a Rob Selecki specimen. Rob runs the Osrox and crystal, can't remember, crystal something business here in Australia, and he's quite often he can be found at places like Tucson. And then we have quite a cute one here, where the the pyrite crystals have mostly grown just on the tip of the calcite, which might be some sort of not epitactic, but something similar that's caused it to mainly grow in that one area. This one is from an obscure locality called Browns Creek in New South Wales, but I particularly like the surface of the calcite crystals. This has got goethite on them, but the texture there is really quite nice. And I see that came up with a I presume you can see that it's got the Mindat photo reference or link there as well. That's because all of the majority of the photos in the book, being a PDF, you can click on the photo and go to a higher resolution version of it. Not going to do that here today, but you can do that. Another one from New South Wales, again showing the red fluorescence that is quite common in Australian calcites. And this one's from Tasmania. It's one of my favourite forms of calcite, where you get this sort of like dogtooth crystals that occur in little, I suppose it's like an exsolution area of the calcite crystal, and then maybe the calcite is regrown a bit, but you see that in one or two localities, not very many, but it's quite an interesting look. And Bundoora is probably one of the best known zeolite localities in Melbourne of recent times. It's no longer available now. It was originally a quarry up until the mid to late 1990s. Then it was used as a refuse tip, and then it was filled in, and I believe now it's been built over. but it produced a range of very interesting minerals, and calcites in particular. This is like a forest of dead trees, this one. Excuse me. And this one dates back to my very early days of collecting minerals. When I first got married, my wife and I were renting a unit in a place called Niddrie, which is an outer northwestern suburb of Melbourne. And there was a large quarry, or relatively large quarry, in basalt, just behind where the units were that we were living in. And I used to wander around there and have a look. At those days you could get into places like that. And I went back a few years later after I got interested in minerals and actually found calcite and also aragonite specimens that I hadn't seen when we were living there, but I wasn't looking. And I went back there about 5 or 6 years ago just to have a look. And the quarry has disappeared and is now just a small lake with houses all around it. And you can still see the quarry wall on one side, what's left of it. But that's it. There's nothing else there. And then over in Western Australia, we've got a little bit of cobalt getting into the mix at Wim Creek. Wim Creek is best known for its wolfenite in Australia. Moving on to Caledonite, it's nowhere near as common as, say, the occurrences in England, but it does form in the same way, just as tiny aqua blue prismatic crystals. And it's only been found at 3 or 4 localities. And this is one of them. This is from Broken Hill, but in slag. And this is serpurite at the front, and the little cluster behind there is the caledonite there and there and down here. So very tiny crystals. Excuse me. Moving on to a rare bismuth oxide, cannonite. Bismuth oxides can be a real pain to work out what you've got without analysis. Cannonite's been found at 2 locations, and it is the colourless crystals that you can see dotted around here. It's with other, there's at least 2 other different bismuth oxide minerals there. There's yellowy coloured one here, and the fibrous ones. Carminite is again is fairly rare but abundant at places like Broken Hill. It occurs as red to almost black crystals. And you can see here that the red crystals, the individual red crystals dotted over the surface of what is probably budantite or segnetite or somewhere in that series. Again, that's one that you can't pick unless it's generally unless it's analysed. But the Carminite's relatively easy to tell from. But Morbiite is probably the other one that's close to it in terms of habit and colour, but they are different. And here's one that's really, really dark, very dark crystals, and quite large crystals too for the occurrence. Carrboydite is a nickel sulfate, and the type locality is the Carboyd Rocks mine in Western Australia. There's a few nickel deposits over there, very old rocks. And carboydite occurs as a secondary mineral. It's not necessarily that attractive. This one's sort of a greyish green colour, botryoidal coating, but it does occur as brighter green at times. Moving on to cassiterite. Cassiterite is, or tin mines, I should say, are relatively common on the east coast of Australia. There's quite a lot of granites running from Queensland all the way down through to Tasmania. And so what I've done here is listed quite a few of the occurrences. Probably the key ones here are the New England area in New South Wales, and places like Ellesmere, where you get quite large crystals and very sharp and very well known. And in Tasmania, where are we? Rossarden. The Rossarden area is the other key area. And this is one example of Ellesmere, quite large, relatively large cassiterite crystals on a smoky quartz. This came out of a pocket quite a number of years ago, and there were two fairly large specimens. The other one is in the Minerals Heritage Museum in Brisbane, and is a bit broader than this one. It's about twice the width. This one used to be in my collection, but I traded it for other minerals at one particular time. And I think it's since moved on to another collector who's a bit of a specialist in cassiterite, so it's gone to a good home. Another one from Ellesmere. I haven't got a scale on that one, but it's probably a couple of centimeters across that main crystal there. This one's a little bit more complex. It's got a fair bit of twinning in it, I think. If you're good at crystallography, you'd probably pick a few of the twin planes, but I think it's probably got some spinel law twinning in there. I'm not an expert in that, though. This is a very unusual one that in South Australia, cassiterite is uncommon. And it's got a little quartz crystal in the middle as well. Excuse me. And again, it's twin. And this came from, or was given to me by Albert Chapman, who some of you may have come across in the earlier days. Albert was a Sydney-based collector and particularly strong in Broken Hill minerals, and traded widely over a number of years. And I got to meet him probably 25 plus years ago, and he gave me this little specimen that he'd collected himself in South Australia. Of course, cassiterite, being fairly robust and heavy, is found in especially called tin leads, alluvial deposits. This particular one here is from northeast of Tasmania. It also includes a few bits of zircon, the orange coloured ones there. There could be some black spinel in there. There might be a bit of quartz or topaz, sapphires and those sort of things, which all form in the same alluvial deposits, but the vast majority of that is cassiterite. And from Rossarden, the other major one, so this is at the Zeehan School of Mines in Zeehan, and the label here, even though you can't see the right hand side of it, that label is about 90 millimeters across, so that's probably a 75 millimeter wide cassiterite crystal. Another one of the minerals that is common in terms of the number of localities is cerussite. And again, I've listed just a few of the key localities here, but Broken Hill, again, is one of the main ones. Rum Jungle is quite well known from. The so-called chrome cerussites in Tasmania, Magnet and the Dundas mines. Yeah, they're probably the key ones to note. And this is another Rob Selecki reticulated cerussite, and that is very large. That's 25, it's probably going to be close to 50 centimeters from there to there. So it's a very large specimen. Not quite so big. This one's probably about 15 centimeters across at the in the part of the Petter collection in the Tasmanian Museum and Art Gallery in Hobart. We've got a small one here from Mineral Hill, which is best known for its azurites, or azurite and malachite. And this is a very small reticulated one. It's got it looks like a secondary coating over the top of the original one there too. It's quite an unusual form. Unless it's a coating of another mineral, maybe even calcite or something like that. I don't know for sure, but it looks very lustrous. Rum jungle, still a bit of reticulation happening here. And then we have the chrome cerussites, which has very little chrome in it from the analysis that have been done, but it's still called or referred to as chrome cerussite by people. And can be pale green through to a yellow, and can be translucent or almost transparent, but translucent through to opaque. Excuse me. And then a tiny little crocite sitting on a Capimine cerussite with white cerussite there as well. This also can occur with dundasite. There might be some on this specimen elsewhere. And one which was quite unusual in Victoria, we don't have much in the way of oxide zones of ore deposits. We have lots of gold and lots of zeolites. And there's only a few places where there are sort of base metals. And this particular one is a mine called Fiddler's Reef Mine, and it's about 45 kilometres away from where I am, and I was fortunate to be able to go underground there a couple of months ago. This wasn't collected on this particular trip. This actually dates back to the late 1970s, but there was a sulfide zone apparently that was about 1.5 meters wide that they came across back in the late 70s, and this came out of that. And a little Western Australian one, very nice little reticulated specimen. The black at the bottom there is the mount, so you can see that's it's a fairly small specimen. And no, I did not mount it. Chabazite, we've got 3 different chabazite species found in Australia, but the vast majority of chabazites are unanalyzed, which means that you can't necessarily determine which one it's likely to be from any particular locality unless there's been some analysis published. Some there has. So you can see down here we've got at Gads Hill and Giblin Street Quarry and Lyawini in Tasmania, Ralph Bottrell's analysed that as Chabazite Ca, and then at these localities in Tasmania it's Chabazite Na. So in some cases we've got it, in some cases we don't. But it is widespread, particularly in the basalt. So Ardglen is one of the better known New South Wales deposits, and this is, you know that Chabazite is generally, when it's untwinned, it's almost looks like cubes. The angles are just slightly less than 90 degrees, and it can look like cubes. But the more twinning that occurs, the more hexagonal outline you get. And this one here, you've got that hexagonal outline, and this is the C. Looking this way is the C axis, and the pinacoid, or the top face of this determination, is made up of these little pseudocubes, lots of little ones. It's very similar to material that's been looked at in detail in Bundoora in Victoria. That's where this was first identified as actually being little pseudocubes, and it was through high magnification that they actually found it. And the same thing has occurred here in Ardglen. This is where we've got a little bit of twinning. So you've got an interpenetrant twin. You've got one here and one here. And there it looks sort of cubic, but it's not. Not quite 90 degrees. The same with that one. There's little blobs of goethite. One with copper sitting beneath it from Bundoora. these are my favorites. So C-axis runs down through this way, and you get this sort of like a concertina effect running through, which is a symptom of the twinning as well, I understand. And there's Phillipsite up here on the top. Sometimes these faces, these terminations, can be quite transparent looking through the crystal, but you can't see through it on the sides because it's more opaque looking on the sides, or the other way around, as in the case of this one. So this one here, you're looking directly down the C-axis in that direction. And this is one sitting on Ferrone calcite, but also here is a little andesite crystal, and I didn't actually find that until I did the photograph. I didn't see it under the microscope. As you can see, that's only 3 millimeters across the width of the photo. Oh, hang on, sorry, we'll let Henk in. But yeah, that was a nice little surprise, that poking up in the background there. And then Flinders is probably the best known locality for melanite and chabazites, and was listed early on in Dana as well. We were down there on a field trip earlier this year and still able to find plenty of material there too. It's part of a national park now, so you have to have special permission to get in. But it's a nice place to visit and spend a day on the coast. And then down in the southwest of Victoria, we've got another defunct quarry these days at Portland, and here the Chabazite occurs with andesite and andesine and augite and a few other minerals, calcite as well. But again, you've got this sort of hexagonal around this way and sort of slightly elongated, similar to Bandura material, except these terminations are not flat. A fairly common post-mining mineral, chalcanthite, but probably would be more common if it wasn't water soluble. Excuse me. So it does occur in quite a lot of dumps and so on around Australia in copper mines, just as an efflorescence, and generally looks sort of pale blue, crusty material like that. I collected that one myself at North Parks. Central Balfour mine on the west coast of Tasmania has formed these crystals that sort of twisted as they've grown. And this one grew in, there was a cavern at Wim Creek apparently that had a blue pool in it at one stage because of the all of the copper there, and this would have crystallized out of that. So it's actually formed underground, which is probably why it's it looks more like a homegrown chalcanthite crystal. Chalcoalumite is a rare one. It's only been found at 2 localities, and that's at the Mount Oxide mine in Queensland and the Orieko mine in Tasmania. And I remember when we found the Orieko mine specimen, we thought it was the first occurrence of chalcoalumite in Australia, but Bernie Day had found some at Mount Oxide, had it analysed and got it published. So we became the second occurrence in Australia. The Queensland occurrence is these pale blue sort of platy crystal groups. In Tasmania, and I don't have a photo of it, it was more like a pinkish crust, so probably less copper and more aluminium as well. And again here, this is another one from Mount Oxide with the light blue Chalcoalumite. It's quite a rich specimen with cyanotrichite, I think, down here. And I can't remember what else, but there's a range of copper minerals comes from that mine. And chalcosite being generally a sulfide that occurs near the base of the oxide zone or supergene zone, can form some quite nice crystals. The ones in Gunpowder, the Mammoth Mine, and the ones in the Telfer Mine are probably the best known in Australia, but it occurs elsewhere as well. And this is one of the Mammoth Mine ones. So pseudohexagonal, I think it's pseudohexagonal, not hexagonal crystals. Very, very sharp crystals. At Mount Gunson, it occurs with other sulfides, and one of the problems that you have with sulfide, the identification of sulfides in Mount Gunson, is that you really have to analyze a lot of them. So even this specimen here might have 3 or 4 different sulfide minerals present, and you just don't know. But the chalcocite is in the center there. Chalcopyrite is a zinc manganese oxide that occurs mostly at Reepok Hill. That's probably that and the Dundas mines are the areas where it occurs mostly. And it's like little plates, very similar to hematite in its look. It's a magnet mine. This is one with colorless Chalcite, which is the mineral here. And the white minerals, these ones, are hemimorphite after smithsonite. It's quite an unusual Chalcopyrite is probably the best known copper sulfide, and it's very widespread, but mostly non-crystallized. But we do get good crystals in some areas, and we'll see a few of those, particularly at places like Mount Lyell. So this one's from the Northern Territory, the Pico mine at Tennant Creek. And we've got cepiolite here, dolomite being the base, and little hemimorphite crystals, hematite crystals on the dolomite as well. The Henty mine is actually a gold mine in Tasmania, and probably it's going to be at least 20 years, probably more than 20 years ago now. Some specimens made it out, not of gold, although there was a little bit of gold, but mostly of chalcopyrite sitting on barite and anchorite. And these are the anchorite crystals here that forms the basis of the specimen, but quite sharp and well-formed chalcopyrite crystals. And an unusual one from the Heliumine. It's got this really odd twinning occurring through here. That's a photo that needs to be retaken. It's an old one. And this one is my favorite Mount Lyell one. I don't know exactly what's happening here in terms of the way it's grown, whether it's twinned or whatever, but you've got the main crystal, which is this one, and then you've got these little crystals that are sort of grown on the corners of or on the edges of the main one. And it's a really weird looking specimen, and quite a decent size too, as you can see. Chalcosiderite looks common when you see that list, but it's not that common. It's also can be quite difficult to distinguish from turquoise. There's a complete series between the copper iron and the copper aluminium end members, chalcosiderite through turquoise. But it does occur, the more green it is, the more likely it is to be a chalcosiderite, but color isn't an absolute identifying feature, particularly if it's somewhere near the midpoint on the series. But it's been found at Broken Hill, particularly in the Kintore open cut when that was operating. Excuse me. The man oxide occurrence was quite good, and a couple of the South Australian ones again, and also Lake Boga. So here this is much greener than most specimens and is definitely at the copper iron end of the series. Silver halides. There's a range of silver halides that can be found in Australia. Chlorargyrite is the most common. Excuse me, talking too much. And generally has a fair bit of bromium in it as well. And you get what's known as embellite or bromium chlorargyrite, particularly at places like Broken Hill. It is very light sensitive and can change in some instances in minutes, and other times it takes years of exposure to light to actually change. An example of the minutes one is at Magnet Mine in Tasmania, where I broke open a small pocket that was totally lined with chlorargyrite. That was quite a nice, almost a lime green color, and it changed color in front of my eyes through to a purplish grey. It was very, very quick and very disappointing when it does things like that. I didn't even have time to sort of cover it up and hope for the best. Broken Hill, in the early days in particular, it was actually an ore, a silver ore. There were masses of this material that were mined just for the silver content. And this one's 35 millimeters in width, so it's a small one by Broken Hill standards, but it's a cluster of crude crystals that has started. It's also been exposed to light on one side at some point in time, so it started changing color over this side, but it's still quite fresh and green on the other side. Another Broken Hill one, but more distinct crystals, so cubes with modifications, octahedral modifications on them. This is one of the ones that I pulled out of the Magnet Mine, and as I said, it changed to a purplish grey, and then stayed that colour basically. When you look closely at this, you can still see hints of green, maybe here, maybe a bit here, but most of it is just it just changed very, very quickly, and I couldn't do anything about it. It's a pity too. It's quite a reasonable size piece. That the actual pocket produced about 10 or so pieces about this size. In Dundas, we've got the Chromite mines down there that have silver predominantly in the galena as part of the galena. Some of that gets out occasionally and forms as chlorargyrite, but it's pretty rare. And then we move on to chromite, which we're getting close to the end actually. So chromite, it's either, well, it's mostly as black grains or black silvery grains in alluvial deposits, or it can be found as massive material, as in kulak, or in as individual crystals in serpentine, which is where the alluvial deposits are generally derived from. And a lot of those alluvial deposits also have osmiridium in them as well. And if we have a look, this is a beautiful specimen of massive black chromite. It's pretty rare to actually find it like this, I have to say. So it's a bit ugly, but sometimes black minerals can be ugly and interesting. Now this one is interesting. So this is alluvial chromite from the Roaring Meg Creek in northwest of Tasmania. And what's happened in this creek is a local caddisfly larva has opted to use chromite grains to build this coiled shell that it lives in while it's in the nymph stage, in living in the water. And then it's then become a full-blown caddisfly, and it's left these things behind. I have heard of other places in the world where it's used things like grains of garnet or sapphire or whatever a similar type of caddisfly larva to build a structure, but I'd never seen it before until I came across these ones from Tasmania. And they're all very sharp little crystals, so the chromite hasn't gone very far from its source either, which is interesting. And there were in the Dundas area for quite a long time, that's where stitchite was first found, and there was a lot of conjecture as to how the stitchite actually formed and what it formed from, because chromite is quite unresponsive to change. It doesn't easily alter. But you can see here that these purple stitchite areas have got little black pieces of chromite still in them. So they obviously were at one stage chromite grains, and they've altered to, in whatever fashion they managed to alter into stitchite. So the source of the stitchite, the chromium in the stitchite, is chromite. There was some thought it might have been some other secondary mineral or whatever, but it certainly appears in this case. This is a polished face. It's the chromite that is the source. And that is the end of part 1 of the C list. So if there's any questions, just let's stop sharing first.
Nice.
Hank, you're muted. Still talking.
Steve, how rare is the chlorargyrite at Adelaide?
It's pretty rare. It's pretty rare.
Because I know Adam will bring me a few extra things every year, but I've never gotten a chlorargyrite from him.
Yes, there's not that many. He may actually have one. Be well worth getting in touch with him before he heads over. And you never know if he's come through. Excuse me. You never know if he's actually come across any new stuff in his mining. The biggest issue there is that they're mining crocoite. So most people that have mined crocoite over the years, like Frank Mikhailovich and so on, have only focused on the crocoite, not on any of the other minerals. Occasionally cerussite, but not much else. Adam's a little bit different. He'll look for things that don't quite look the same. And so, for instance, I've got a mimetite from there that, no, actually that dates back to Frank's days. I've got a mimetite from there, though. I think Adam might have found one small patch of mimetite, but the chlorargyrite is much rarer. But it's worth asking.
Right.
Henk, you're still muted. I think you were trying to ask something before.
Right.
Ah, there we go. Yes.
Good evening, everyone. I was a bit late.
Hi, Hank.
Hi. So I just fell in half of the presentation. So I will take a look at the first half when it's online later.
Okay. Well, you also would have missed the fact that we've got you lined up for next month for the Azores.
Yeah, no, I already knew that.
Okay, good.
It's ready. It's already standby, so
Good.
no problem.
In the can.
Yeah.
Steve, when the
Yes, Liz.
CPAN Mineral Show takes place, are there still field trips or at least trips provided out to the Crocoite mine, the Adelaide?
At the Zine show?
Yeah.
Usually, I haven't been for a couple of years because of COVID and related stuff, but
Right.
yeah, I'm not sure if they've got anything specifically planned. Adam generally has a stall at the show, as you know, and I think he's operating it most of the time on his own. So
I was there last December.
yeah,
I just sent Adam an email and he just let me in there, so no problem.
yeah,
no
it's
problem
just
whatsoever.
The
Yeah.
gang material that they had out there yielded a lot of interesting things.
Yep.
And, and it was, I'm still going through a couple of small pieces that are really just chock-a-block with stuff that isn't crocoite. So,
Yes, it's like I said before, the vast majority of people mining there have only been looking for the crocoite. In fact, in Frank's days, Frank Mikhailovich, rest his soul, he would bring a big chunk of crocoite crystals out and he'd put a hose on it, and any bits that broke off, they just broke off. That was it. Didn't care. And what was left was what he sold. So there wasn't even any care really taken with, particularly with the more fragile specimens. Whereas Adam has a different mindset. So
Luckily.
He's a really nice guy.
yeah. So I dare say here, I caught up with him when I was in Tassie a month or 6 weeks or so ago, and it looks like there might be some more material coming out for next year's Tucson show. Maybe there's some signs of stuff. So yeah, it'll be interesting to see what comes out. But it's more crocoite. So
That's what the world wants. Huh? Yeah.
All right. Any other questions? So everybody's got lots of Australian minerals in their collection.
No,
Yep.
Yes.
is
I
the
do.
answer.
I have a question,
Thank
Steve.
you.
Kathy.
Hi.
Hi.
What inspired you to write this book?
Okay. I like to share information as widely as I can. This particular one, I didn't really plan to do it early on, but when I got to the end of, so I produced the Lake Boga book, the Flinders book, and the Spring Creek books, and I just thought, oh, why not go big and do it, because nobody else has done it. And it's obviously going to take quite a long time to get through. As you know, you get the monthly Mineral Chronicles. We're into the letter G now, so I'll be publishing D to F fairly soon as a separate volume, which will probably be a similar size to the first volume. But the benefit that I get from it personally is I get to find out a lot more about minerals in Australia, and I get to find out a lot more about minerals in my collection. So I've got there's 1,500 plus species that have been recorded in Australia, and I've got over 700 of those represented in my collection in Australian specimens. So having that to work with means that there's a good chance that I can get enough coverage in terms of photos for other people to benefit from it as well. And as you know, when we have a particular species, where possible, it's not just one photo, it's photos of different forms from different localities to try and help other people if they're trying to identify their minerals in their collection as well. And it has the obscure ones in there too that you're probably never going to find and I'm never going to get. But for completeness, try and include those too.
Steve, just before we started, I sent you a email with an attachment to it that is a very interesting look at the garnet group. I think I sent it to the publisher address.
You did, but I think it's only the JPEG. It's just the picture.
Yeah, well, there was a note to it, about a 2-line note.
Oh, okay, yeah. But yeah, I've seen that.
You're willing to share that? I got that off, found that on the internet, and I thought it was very interesting. and you're perfectly welcome to share it.
So I'll just do a share screen so people can see what that is. I've seen this drawing before.
Oh, yeah.
Oh, yeah.
Yep.
Oh, yes.
I see
Yeah.
that one.
I use that.
You
I
see that
use
before?
that.
Hmm.
I use that in every presentation where garnets
It
play a
is-
role.
That's been done by Lena. Lena's an artist. I think I'm connected to her on LinkedIn. She does some superb work. I didn't notice who it was from before, but yeah, that's probably where I've seen it. Is probably on LinkedIn. I'll see if I can track it
It's
down.
free on the internet.
Yeah, it's very, very interesting. Okay, Martin's gone, so hopefully
Yeah.
he'll be home next month. Yeah, it'd be good.
Right.
All right. If there's no more questions, we might finish up. It's just coming up to 7 o'clock here anyway. I might just have a quick look and see. Oh no, it's got colder. It started off as -2 degrees. It's dropped down to -2.4. So nearly
Yeah, it's in the
daylight.
middle of winter. Yeah. Well,
We've
Yeah,
had a couple of
sure.
cold nights. So, all right. And we'll see you all again in a month's time with Henk
Yeah.
on the Minerals of Azores.
yes.
And very much looking forward to
Scenery,
seeing that.
scenery
Yeah.
and minerals.
Yep.
Wow.
Excellent. Excellent. All right.
Okay.
Thank you, everybody,
Yep.
for attending.
Okay,
Thank you
thank
so
you very
much.
much.
Thank you so much.
That was
Sorry,
great.
nice.
sorry.
Bye, everyone.
Bye.
Wonderful.